I consider a very simple use case in robotics. Then I discuss this simple example in the context of current general purpose programming languages. Then I propose a layered programming language. Here's the simple use case. There are three things in a line. There's me, there's a humanoid robot, and a small box from Amazon, like in this picture here. I want the robot to hand me the box. The robot simply reaches with its right hand, picks up the box, then swings its right hand in a large arc towards me and drops the box in my lap. The code for this is, give me the box. I will call that kind of code DI, meaning design intent. That's the spec, but what actually happens underneath? The robot's right hand cannot reach me unless the robot turns its torso too. To look natural, the robot's eyes must track the box in its right hand. The eyes can turn only so far, so when the range of eye motion is used up, the robot must turn its head. The eyes move from right to left. When the leftmost position is reached, or before that time, the head must turn a bit, and the eyes must snap back to the rightmost position. Furthermore, the robot's hand can't reach the box nor me unless the robot moves its arm, not just its hand. And so on, more and more detail comes leaking through. How would you write this code in a functional manner? It's a mess of details. The details depend on the underlying hardware. Imagine that I'm the CEO of a robotics company. I don't want to waste my time specifying the mess of details. That's your job. You're the engineer. In fact, details are the job of engineers, and coding is the job of implementers. Engineers think things through, but they don't actually write code. Here's an analogy. In building construction, like putting up a house or an apartment building, there's architects, engineers, blueprints, and construction workers. Who builds the building? The construction workers, not the architects nor the engineers. The human body has hundreds of joints and actuators, muscles. The human's intent is set by the human's consciousness. Then this single-threaded consciousness gets out of the way and lets the actions happen without trying to micromanage the actions. For example, we don't walk through a closed door by commanding the fingers to grasp the doorknob and turn it, then command the arm to pull back. We simply will it, and it happens. Most of the popular computer programming languages that we use today are made for writing micromanagement code. This is an important point. Most of the computer programming languages that we use deal with micromanagement. And what we want is the opposite of micromanagement. An aside, the best book on the subject of human autonomic actions that I've read is The Inner Game of Tennis. Most popular languages are really single-threaded at heart and would be great for programming the robot's consciousness, but that's not how we use these languages. We have bolted ad hoc assembler-like operations onto the sides of languages. We call them thread libraries to allow even more micromanagement. I think in a robot, we would want the eye controller to send an event to the head controller to tell the head to turn. Programmers tinker with events using ad hoc flat concepts like pub/sub. By flat, I mean unstructured, the way that assembler was before the structured programming revolution came in. We could use a similar revolution to help structure events. For example, something like structured message passing. In fact, I think that we should want to build this kind of software in layers, then stack layers to make the final robot. So the pertinent question is, how would I start to program this? I see about 4 main steps. First, I would speak the DI phrase, give me the box, into a microphone. Then I would use AI speech conversion to turn this spoken phrase into a blob of text so that the current text processing tools can be used. Parsers and scanners and lexers and that sort of thing. I would use OMJS to grok the text phrase, give me the box. OMJS, in my opinion, is the best parsing technology we've got at the moment. I would use Fabricator, to convert the grokked phrase into more lower level phrases like figuring out where I am, make a plan to grasp the box, make a plan to swing the grasped box to the target, make a plan to release the grasped box onto the target destination, i.e. drop the box onto my lap, make a script of commands to carry out plans 1 to 4 in sequence from 1 to 4, and then finally to carry out the script after making all the plans. Fab itself is a tool that I created in OMJS to use as an adjunct to OMJS. OMJS expects you to write JavaScript code to do the semantics. Fab is just a layer of syntax over that. It helps me avoid having to write JavaScript directly. Obviously, each of the plans 1 through 4 contains sub-plans. For example, plan 3, make a plan to swing the grasped box to the target, might look something like tell the hand to swing over to the target. The hand software then needs to tell the arm software to move at the right time. The arm software needs to tell the torso software to swivel at the right time, and so on. The eye software needs to tell the head to swivel at the right time. The head software needs to tell the torso to swivel if it's not already in the correct position, and it needs to do so at the right time. The eyes have a restricted range of motion. The head has a restricted range of motion. The torso needs to turn to allow the head to turn all the way towards the target. The head needs to turn all the way to the target to allow the eyes to look at the target. This is how I think about this. As you can see, it's a bunch of layers. I would like to program one layer at a time, concentrate on one layer, not concentrate on the whole thing at once. Once I've written and tested a layer, I want to put it away and forget about it and just use it later. Flattening the layers to fit the functional programming model is, in my opinion, make work. And it's wanton obfuscation of the original design intent. You have to reverse engineer the code to try and figure out why someone wrote the code that way. What is a programming language that handles layers? At the moment, I think we only need 2 simple concepts. We need leaf code and we need container code. Leaf code is what we usually do these days with programming languages and functions. Python would be leaf code, Haskell would be leaf code, Rust would be leaf code, etc., etc., etc. Leaves produce results by creating messages, not return values, but messages, and they leave the messages on their own output queue. The messages don't get acted on right away the way it does when you return a value from a function. Container code doesn't need to do much. Containers contain other components, leaves or containers, recursively. Containers shepherd messages between their direct children using routing tables. Containers produce results by creating messages and leaving them on their own output queue, just like leaves do. Containers look like components, and in fact you can't tell what a component is unless you open it up and look inside. And in most cases, you don't want to bother opening it up, you just want to use it. Containers shepherd messages in one of 4 ways. 1 is down, 2 is up, 3 is across, 4 is pass through. Leaf code can't shepherd messages. A leaf can only leave messages on its own output queue. Now let's look at the 4 kinds of message shepherding. Down. A container gets an input message and reacts to it by moving the message to 0 or more of its own children. Up. When a child creates a result message that the container wants to use as its own output, the child pushes the message up to the container and it goes to the output of the container. Across. This is what we normally think of. It's child-to-child messaging. A child cannot and must not refer directly to any other child. A child leaves its output message on its own output queue, and then the parent of the child handles the routing of the message. The message can be moved to one or more other children, or the message can be completely ignored and not moved to any other child. The parent makes this decision. This is what I call routing policy, and that's what we know it as too. And the final possibility is pass-through, which is mostly an edge case for empty containers or stubbed out containers. So a container, when it gets an input, can take the input and move it directly to its own output, and that's a pass-through. Layering. What I really want is layering. Given that containers are recursive, I think that what I've just described handles an infinite number of layers. The secret to what's going on here is quite subtle. Most general-purpose programming languages like Python, Rust, etc. use functions, which boil down to the use of the call stack. The secret to layering is to use queues instead of stacks. Since the functional notation is ingrained in our consciousness as needing a call stack, I would suggest using another notation for queue-based message sending instead of function syntax. The prerequisite to layering itself is something I call 0D, zero dependency. At the moment, I'm tinkering with various syntaxes as shown here. I use slash to mean call method instead of dot. Dot is reserved only to access static attributes. Slash means call. And the parameter list, in this case, contains a thing that's a message. The message contains 4 fields. It contains a port data and 2 debug things, which is self and the causing message. And I'm using special characters to denote where these things are coming from. The variable port comes from the input parameter list of the function doing the calling here. Same with data. It's got a row in front of it, which means that whatever data was passed in as a parameter is being used here. S with a hat on top of it, should means self. And again, row message means whatever message was passed in as a parameter, use it here. The experimental code can be found here in my GitHub, guitarvita/0D. Make sure you understand this is experimental. It's not finished and not necessarily directly useful, but it shows the concepts. Also note that the notation I'm using plays with a bunch of other notions like orthogonal programming languages, Unicode brackets for messages, Unicode symbols like sh and row and slash for method invocation and so on.